Welcome. This presentation will be presenting a disease known as myotonia congenita. Myotonia congenita is an inherited myopathy, a disease that causes problem with the tone and contraction of skeletal muscles. It doesn't cause muscle atrophy, but rather muscle enlargement and increased muscle strength. Now, there are two types of myotonia congenita, the Becker type and the Thompson disease. Here are some basic information of the disease that we'll be talking about in great detail today. The main problems faced by people with this disease are delayed muscle relaxation and muscle stiffness, which is typically provoked by sudden loud noises. In addition, muscle stiffness is triggered or aggravated by exposure to cold and fatigue. Following the stiffness would be muscle weakness. The stiffness is relieved if the individual continues physical activity or quote-unquote continues warming up. Before we talk about the signs and symptoms, we need to understand what myotonia congenita is. In addition to the introduction, it is a disorder of voluntary skeletal muscle characterized by and response to stimulation of certain muscle fibers. As a result, there is pain and spasms of the affected muscle after forceful voluntary contraction, which leads to difficulty relaxing the muscles. Characteristic symptoms include difficulty starting to walk or run, arising from a bed or chair, or relaxing the hand grip. In Thompson disease type myotonia congenita, the signs and symptoms become evident from infancy to approximately 2 to 3 years of age. The muscles affected the most are the muscles of the legs, hand, or the eyelids. In more detail, for example, involvement of muscles that control movement of the eyeball may lead to temporary episodes of double vision or abnormal deviation of one eye in relation to the other. In addition, in some cases, if myotonia affects muscle of the throat, affected individuals may have difficulty with chewing, swallowing, or attempting to talk after a long period of silence. And so, we have to ask ourselves, how does it start? Numerous mutations in the same gene have been identified in an individual with Thompson types myotonia congenita. The gene known as CLCN1 has been mapped to the long arm Q of chromosome 7, 7q35. And so what are chromosomes? Chromosomes are found in the nucleus of all body cells, pairs of human chromosomes number from 1 to 22, with an unequal 23rd pair of X and Y chromosomes for males and 2 X chromosomes for female. Each chromosome has a short arm known as P and a long arm identified by the letter Q. So, 7q35 refers to the band 35 on the long arm of chromosome 7. Going back to the signs and symptoms, rippling muscle disease is a rare genetic disorder in which mechanically triggered contractions of skeletal muscles spread to adjacent muscle fibers, potentially causing visible rippling movement of the muscle. Next slide. And so normally, in a relaxed muscle cell, chloride channels in the cell membranes are open, allowing a current of negatively charged chloride ions to pass into the cell. This creates a negative membrane potential, meaning there is an accumulation of negative charge on the inside of the membrane relative to the outside. A nerve cell triggers contraction of the muscle cell by turning the membrane potential from negative to positive. Chemicals from the nerve cell stimulate the opening of sodium channels in the muscle cell, causing an inward current of positively charged sodium ions. Now, when the positive currents overcome the negative chloride current, the muscle cell contracts. For muscle cells that are affected with myotonia congenita, defective chloride channel reduces the entry of chloride into the muscle cell, hence allowing excess sodium to enter. Therefore, just a small amount of sodium influx is enough to change the membrane potential and cause contraction. This contraction is sustained by buildup of positively charged ions at the muscle cell membrane, and relaxation is delayed. Additionally, reduction of muscle chloride electrically destabilizes the muscle fiber, which is responsible for the repetitive action potential firing characteristics of Thompson disease. Looking at this diagram, we can see clearly what goes on between the relaxation state, the contraction, and how myotonia congenita affects the human body. There are specific therapies as treatments that are supportive. The most effective medications are those that help to stabilize the muscle membranes, and medications that have been prescribed to help treat have included medications such as phenytoin, acetazolamide, and carbamazepine. In addition, skeletal muscle relaxants such as dantrolene sodium and sodium channel blocking agents such as antihistamine are used to treat Thomson diseases. Thank you for listening to this presentation, which gave an introduction of what myotonia congenita is, the cause and effect. Thank you for listening. This is the reference list that was used that provided most information for this presentation.